So I would locate this Logit R markdown file, RMD file, and then Logit data Excel file together, the same directory. And I'm gonna open RStudio by clicking this R markdown file. So if it's a source, then it's not easy to looking at. So I will choose a visual, okay? And then you may see the some kind of the line here, the certain package is not installed. Then you can just click install. Then you don't have to install the individual here. So this is a linear probability model. So I have to read the Excel file. So that's why I don't know you already installed it, but I think in the first week I introduced this package, but I don't know you installed it or not. If you don't, you have to install the package, or you may install when there is a kind of warning sign. Would you install all the packages required? And then it includes multiple sheets, so I can specify the which sheet data we're gonna put it in. So I'm gonna put this my data. So I learned this one, and then this one read through the data from my data here, as you can see. And then this plotly is the kind of the a lot of different plot drawing graph function library. So we will bring the brought the plotly, and then I set the x and y's are our x1 value, y is x2 value, and then I will put the y to the z value. So I will draw the 3D chart, and then I can use the title. What will be the title? Actually, you don't need to, if you just need to see the data, you don't need to put the sign. But trying to see, this is a x-axis. This is kind of optional, y-axis and then z-axis. Okay, so if I draw, you might wonder this dollar, the percentage, and then this percentage means you will put the result of this one into here. So actually layout function will get some plotting output, and then we will add, but this output will be go into the input of the next function. So when you type in the layout, we can skip the one input here. You run this one, you should be able to see this chart. So I will make a bigger. And then the one thing is interesting is you can click here and then drag and then change the view. As you can see, y value is all 0 or 1. Everything is on the bottom or on the ceiling, right? So you can see here, actually this side is a bottom, and then as you can see that the other side is kind of the ones, right? So it's not clearly cut off, but what if we just using the regression, simple linear regression, you will draw a certain line, and then that line will not be fall all in between 1, 0, and 1. Okay, so I will go back. So if we draw the just 2D, and this will be our regression line, and then we can find out our coefficient, right? Just simply learn the regression. Intercept is minus 0.8 something, and then x1 is a 0. This is all coefficient, so we can create the the model, right? It's a p equals minus 0.8682 and so on. So if the x1 is 20, x1 is 20 and x2 is 30 case, we just plug in the 20 and 30 here. Then if you calculate it, you can get a 0.2818, which is like a 28%. Or if it's 30% and 30%, then you can get like a 0.4698%. You can, no, percent is here, this is percent. Right? However, the problem is, it's like this. If we have like a 60% of the down payment and then 30% of the income to loan ratio, then the probability of approval will be 1.03. This is a 103%. That doesn't, in probability you cannot have a more than 1. And also, if the down payment is just 5% and ratio is 30, then you can have a negative probability. Right? It's a pretty small negative, but still it's a negative probability. That is kind of the drawback of linear probability model. Okay, so the major shortcoming of the linear, actually this is the LPM, is the predicted probability can be outside of 0 and 1. That's not good. And then linearity is questionable. What I mean is do you think that's actually the linear? If you take a look at this one, yeah, we do the regression, but do you think this is a really linear relation? Therefore, the people created a logistic regression. So logistic regression model is still we will use a regression techniques because we will find out what is a beta 0, beta 1. So this is a true number, so we will find out B0, B1, and right up to the BK. But we will set the probability in this way. This is the exponential, and then the exponential is actually our regression formula. So P equals this exponential divided by 1 plus that same exponential. So we will talk about it. This is actually not a probability. This is what we call this odd. Logistic specification will guarantee the predicted probability will be 0 and 1. Later you will see why I can guarantee whatever the input you bring in, everything will be between 0 and 1. This case, this is not linear, so ordinary least square is not good method. We cannot estimate, so we will use a maximum likelihood estimation to find out all the numbers. And this is the just drawing linear probability model, which can go down below the 1 and can go up to the 1. But instead of that, the logistic will have a what we call this is a sigmoid function, which has a form of this form. So it has clearly the minimum value and then also the maximum value here. Okay, so that's why we can guarantee the form of the line is this shape. So that's why it cannot go above 1. It cannot go below the 0. So using this one, so again, this is the P, is the probability of Y equals 1, and we assume this is form, and then we just trying to find out what is the best B0, B1, and B2, so that we can find out the most likely, maximize the likelihood. So interpreting the coefficient is different than the linear, but actually it's the same. You can say it's the same, or it can be different, because you cannot tell in the linear case, if x1 goes by 1, y will go up by b1, right? That's how you do it. But here you cannot tell that. If x1 goes by 1, P will not go up by B1, obviously, because there is an exponential, right? But however, this B1, X1 goes up by 1, then using this, according to this formula, P will go up or go down accordingly. So exact impact would not be the B1, obviously, this because it has passed through this complicated formula, right? So predictive variable has a positive or negative impact, so it depends on that. Examine the impact of different change in the predictive variable. So we cannot just directly tell this will go up by how much. You cannot say that. Okay, so coming back to the loan approval example here. So estimate and interpret the logistic regression model, and then 30%. What is the right? Application with the 30% income to loan ratio. This is the X2, and then 20% or 30% down payment, which is the X1. Two cases. So this is a result of the regression. So since even though this is a logistic regression, this is the same as a regression. So you will have the estimate, which is the B0, B1, and B2. And this is the standard error and z value. So again, we will look at the p value. All of them are the less than 0.05, which is 5%. So we can say all of them are statistically significant. Okay, and then if you have this should be the 20%, right? 30%. 20% and 30%, then you can plug in the number, then you can find out what is the probability, and 30 and 30, and we can find out the probability here. Okay, so how can we do the logistic regression? Do I have to use no, actually Excel doesn't have a logistic regression by itself, so you have to change everything. Is exponential. So it's gonna be really tedious. You can do it, but it's gonna be really hard. So usually some commercial package for the Excel add-in will have a logistic regression model, but Excel itself doesn't have a logistic regression model. So we will use R. We have a GLM. GLM is a general linear model. So GLM, and then you use the same way we did in the regression. Only different thing is we had this part. Family is binomial. Once you set the family is binomial, that automatically this will do the logistic regression. So what I'm saying is the y is binomial. Then automatically this function will choose logistic regression, and then it will do it. Right? And then once you got a model, this is a logistic model, and then we will use a predict function. This predict function also widely used in the machine learning, because this predict function can be used when you develop the machine learning. I mean, train your machine learning, and then you trying to predict a certain part, certain input. you can use this predict function. Once we got a model, so we use this model, and then what will be the prediction data frame. So you have to create the data frame. Actually, this data frame has x1 and x2, right? This is contains 20 and 30, so it will be 20, 30, and x2 is just 30. So you are creating this kind of data frame, and then you put it in. So we can tell this is x1, x2, and this is x1, x2, and type is a response. Then you will get a either what is the probability of the first case or the probability of the second case will be the output of this predict function.